Okay, something drastic. Hey, that's better. Can you hear me now? Hear me now? Cool. Yeah, I've just plugged in USB microphone that I didn't think I'd need to use. Very odd, because I was done a ton of testing this morning with all the microphones and that I've got, like microphones in the cameras and stuff, versus using a USB desk one. And I thought I got them all set up so everything was working well. Oh well, gremlins. Better to deal with them on the first one. There's only you on at the moment. I thought I'd try and do it for a time that people in the US could join as well if they wanted to, but it depends on which side of the US they are. If nothing else, you'll get some boredom of watching me do some soldering, and then you can bugger off back to your barbecue. It's a good point. Hang on a minute. I'll bring a note out. 1 second. Phone, that'll do. Thanks for doing that. Okie dokie. Somewhere relatively safe. So anyway, while we're waiting, let's see if anyone else joins. Um, yeah, PCB. Um, so the idea of this session was just to get one of these soldered up and just show it a quick demo of the interface. So cover this again if anyone joins, but for your benefit. The reason this ended up getting so complicated and where I'm using a Raspberry Pi Pico now was because in order to support all the various games that or versions of Battlezone or the like that I wanted to support, I needed to support multiple control schemes on multiple platforms. Obviously the main one's Vectrex, but then also PC main. And just doing those two are relatively straightforward in themselves, in that I've already got a USB interface for a Vectrex controller that I built that I could use to get it on the PC. But the problem with that is that that's great. It means yet another box to connect up to the controller, unless you've already bought one of those, in which case then you've got it already. But the bigger problem with that is that it only supported a couple of the games on Vectrex. So I wanted to support as many variants as possible. So the main ones are the Pytrex version of Battlezone running the main ROMs, the Stramash Zone, and I was fortunate that the guy that did most of the work on the Pytrex version was nice enough to add in a Stramash zone mode controller configuration scheme into the Pytrex version. So I only had to have one board, which actually this version here, I think it was this one, yeah, this version here, earlier version of the board actually will run Stramash zone and the latest Pytrex version. Obviously a much simpler board, but it won't do things like the Vec Fever version of Battlezone, which is really annoying, and one that I like playing because it is a very good implementation. So I wanted to support that as well. A little bit unfair. I did have a bit of a chat with Thomas, who was the creator. We did a bit of backwards and forwards, but it was a bit unfair of me to expect him to make my life easy and go modify something that he'd written a while back. And also it's an opportunity for me to stretch my skills a bit more and learn some more electronics. So that was the reason that I ended up going to a Raspberry Pi powered one with a bunch of these nice little 4000 series digital analog switches, switch ICs, and controlling them all with the Pi. So basically I'm just using the Pi to host the software that treats these things like you would normal flickable double pole single throw switches. The camera just got off. It did. Second. Also need to fix my camera that's pointing at me because it times out after a while. I'm sure there's a setting. It's my DSLR I'm using. This will teach me for trying to be clever with all the kit that I do have. Anyway, so soldering iron's hot. We are going to tack this in place. Just to hold it. Normally when I'm soldering, I'd use my fancy light that's lighting this up at the moment and use the magnifying glass feature on it, so I've got a better chance of seeing what I'm doing. But I needed the light higher. So anyway, yeah, so what was originally going to be a more complex mechanical build for this controller versus the Lunar Lander one that I'd done previously that you've seen how to go at, ended up being a controller with a much more complicated mechanical build and a much more complicated electronics build, but it's allowed me to learn some new skills, and it's nice to do some coding after probably at least a couple of decades of not really doing any coding. Hey, thanks Eric, welcome. Yeah, well, I had an issue with, for some reason, the microphone in the camera that I thought was working previously, because I've done a bunch of testing today, decided it wasn't going to work on the main event, so I just had to pull out the USB microphone and using that instead. Thankfully that one did do what it was supposed to do. So what I'm doing here is just soldering on the Pico, and I opted to do it without header pins for these boards, mainly just to save a little bit of height, because I'm really tight on space inside this controller shell. As it is, I'm still going to have, with this board layout, I'm going to have to make the controller shell deeper front to back to be able to fit this in. Just because of the way that I've designed the shell, just to try and optimise the print a little bit, but that's fine. It's just minor design changes really, which is to be expected when you're developing something new. So far it's been been a relatively straightforward process of iteration, which is good. I'm just saying to James, normally I'll be using a magnifying glass to see what I'm damn well doing. In fact, I can don this and look like an idiot. Oh, there you go. That's better. I can actually see what I'm up to now. Much better. So this is probably the fiddliest part. It's just soldering all of these. Thankfully it's only 30 connections, I think it is. Not my cleanest work, but not far off actually. Doesn't look too bad. There. That's the one. Let's have a quick look at that. Which is good. Okay. So, and I've already flashed the software on this Pico chip. So once this is built up, I can. Hey Brett, welcome. Yeah. So once this is soldered together, we can plug it in, and hopefully it'll come to life, and we'll actually be able to show you the user interface on it. Won't be able to show you much more than that, but what I will do is mount it in onto a chassis that I have here, which will give you some idea of what the mechanical build part of it looks like as well. So, Brett, as I was saying to the other guys that have already seen some of my work and some of it, and earlier, at least one of them seen one of these controllers in the flesh. What I'm doing is with this Battlezone controller, it's got a lot more complicated than I originally planned, just so that it can support Blue Peter moment. Yeah. I do have one that I made earlier that does work. It's not my first rodeo with doing live demos. It's just my first rodeo of live streaming. Or live streaming on YouTube anyway. I've obviously done a bunch of Zoom calls over the years. Hey, how you doing? Welcome. Yeah, so the reason this got so complicated compared with the original board that I originally designed for the Battlezone controller was this one here, this tiny little thing, and that works with the latest Pytrex build and Stramash Zone, but it doesn't work with the Vec Fever version, and it needs a separate interface to work with the PC and MAME. And then I had other people say, hey, it'd be nice if you could support Atari 2600, for example. And I thought, well, that's a nice challenge. I'll take up that challenge and teach myself a bit more electronics than I knew previously, and do a little bit of coding, which I haven't done for a long time, despite having a very long career in technology. I've not coded anything in anger anyway for probably at least 15-20 years. I just managed people that did a lot of that stuff. So it was a nice opportunity to stretch my legs a little bit and design something that would solve all the challenges I had around making the thing work with as many games as possible, or as many game variants as possible, and also be extendable, so that if I want to add additional functionality in the future, I can do that just with a software update. And hence the reason this thing went from that tiny little PCB version to this incarnation, which still isn't complete. I've got some design tweaks to make. Some of the electronics here is still a work in progress in terms of my understanding and level of ability. So there's a couple of components that I need to add that I've already already added into the design now. I just need to get more PCBs made up, which will happen over the next few days, to get the new PCBs ordered. And for those of you that do any electronic stuff, it's just incredible how cost effective it is to get PCBs made these days, particularly with the likes of JLC PCB that I use in China, and PCBways, I think, another common one that folks use. And the service is just brilliant. I mean, obviously, if you want a quick turnaround, you end up paying through the nose for the shipping. But like these ones, I ordered and had them in my hands in less than a week, which is incredible when you think about how long it would take otherwise. And also another skill that I had to teach myself was the PCB design, which I'm really enjoying. It certainly beats making everything on strip board. Which some of my early lunar lander controllers that I shipped to folks were all on strip board and all handmade, hand wired, which was extremely time consuming and prone with risks of things not working properly. So I agonised for a long time building those things. Okay, so what we've got in here so far is the brains of the operation, the by Pico. We've got these two switch ICs, which are really just acting as switches that are going to be controlled by the Pico and the software running on it. These resistors are just pull up and pull down resistors. So what they do is they basically fix the state of any switches in either on or off as I needed them to be for the initial state before the. So if the Pico doesn't tell a switch what to do in terms of send a signal to say turn this switch on or turn this switch off, they will default to a state that's dictated by whether the signal is being pulled up to the 5-volt level on the board or down to ground. So it's really just to kind of make sure that they're always in a known state if there's nothing controlling them. And then there's a bunch of resistors that need to go on. So let's start putting those in. So these resistors are what take, on the analog side of things, they're what take the, basically mimic the joysticks, the joystick either being fully up or fully down, fully left or fully right, which basically what they're doing is just making the analog joystick a digital device in effect. So these are actually these resistors are the matrix that generates the right output signal, which really is just a voltage on the analog joystick line at the right level to drive the Vectrex. One of the things, if you ever take one of my controllers apart and look at the board, you'll notice I like to get the components in the right, lined up the same way. So resistors, I like them to be in the right orientation. At some point I will be brave and start playing with surface mount components and get the right equipment to be able to solder those reliably, because that will mean that these boards can be a hell of a lot smaller than I'm currently able to make them. Let's fix that. Hopefully that's fixed it. Yeah, it's the it's my DSLR that I'm using for pointing at me. I'm gonna for the next time I do one of these, I'll switch it out and use another webcam. It's a bit of a as this is the first live stream I've done on YouTube. It was a bit of a voyage of discovery to get stuff together that worked, but it's all good. Okay, so let's do these ones. So there's two values of resistors I'm using here. This which form this resistor matrix that does the voltage conversions. These are probably the fiddliest part of the whole thing, just because they're teeny tiny. Another reason I'm terrified of surface mount is they're even smaller. These are bad enough. So James, are you still at your sister's barbecue? Maybe you haven't got me on a big screen or something. That would be embarrassing. Just got to solder. Fiddly. Sockets in. so that A, they're neat, but B, it means that everything can be easily disassembled, so that if anything needs to come apart for testing or a future upgrade, like hardware upgrades or anything like that, it's all nice and easy. They also just look nice. And of course, if you're making something, you want to try and make it look nice. Well, in my opinion, you do anyway. Let's do them ones. And let's take those out before they fall out. Place a bit. Stand to finish them off. These two. Where did that other one go? There it is. So now we can finish them off. Nearly there, guys. How was your breakaway, Eric? Are you still there or are you back now? It. Okay, so we now have one board that looks complete. So that's everything off. Okay, right. So then bits that connect into it. This is where what I'll do is I'll put that out of the way. And I'll grab a chassis. So this is the Battlezone chassis, slightly stripped apart at the moment. So joysticks operate micro switches. The micro switches obviously connect in, and the Pi sees them and operates the switching to generate the right type of output. The design I use for these is, take them off. It's like a camshaft assembly in a car. So basically you've got a shaft with bearings. The shaft goes through this pivot block that the joystick handle fixes into, or the joystick shaft, sorry. Fire button goes through the centre of the shaft, because they'll have the outer shells around them, and then the bearing blocks hold all this stuff together, and then all of that as a flexible grommet, very similar to the original Atari design for their controllers for Battlezone in the arcades back in the 80s, and then yeah, so they give you the restriction on the movement, and then you have these controller shells that clamp around the joystick and clamp through, and the buttons, the fire buttons, fix into the shells, and then you end up with a nice controller handle, modelled on the arcade originals, so that ultimately it'll end up looking quite nice. But the board, so the board has a fixes in, and all of the connectors, basically each of the micro switches goes into its appropriate port. There's the DB9 Vectrex cable that connects into the output to the DB9, and then in addition to that, the only other two things is the mode switch, which goes in there, and the little OLED screen. So this is a mock-up I've been working on, figuring out how I'm going to fit these things into the actual outer shell. So what I've got is the OLED screen itself, then there's a mounting piece which the OLED screen will get glued into, and that gives me the top surface with a beveled edge around the screen. This is a representation of the part of the top surface of the controller. That assembly will then glue into that, and then there's a 3D printed decal basically that sits over the top of it all and will cover up all of these join marks, so it will look nice when it's finished. Anyway, so that goes in there, and what we should be able to do, if I get my USB power cable here, is we should be able to power this thing up. If I've soldered it correctly, it should come to life. There you go, so you get the Battlezone splash screen, and then it goes into Vectrex mode. If I take this board out temporarily, put it up a little bit close to the camera. So it starts off in normal Vectrex mode, which is for Pytrex and Stramash Zone, and then the mode button switches between the modes. So the next mode is Vec Fever, and then after that it goes into USB mode, where you can connect directly to a computer with the USB port, and then use it on something like MAME. It works really well on MAME. And then the last mode is the Atari 2600. And the Atari 2600 is the reason there's two of these chips, these switch chips, because I needed one to switch one of the pins that on the Vectrex is an analog output. On the Atari 2600 it needs to be digital output for one of the controls. The advantage of having done that though, is that turn it off for now. The advantage of having done that is that I should also be able to get it to work on the Commodore 64 and maybe some other versions of Battlezone as well. Maybe even the version that they did, the original version they did on one of the Atari Anthology discs for the PlayStation 2. I think I've got that here somewhere, so I might be able to even test that at some point. Anyway, that's it. That's a build of of one of the boards and a quick demo of the user interface. Hey Mailman, hey Paul, welcome. You're right at the end of it, unfortunately. You'll have to watch the replay. Oh, my camera's gone again. Just fix that. So yeah, actually, as you've just joined, what I'll do is I'll quickly demo the UI, the user interface again. So yeah, oh, let me take that out temporarily. So yeah, the board. Just to quickly run you through what's in here. Let's take those off for a minute. So Raspberry Pi Pico, which is running the software. Hey Brett, running the software. To control these, basically control these switch ICs. These switch ICs are what allow me to take the various inputs from the controller, so the joystick, forward, back, micro switch activations, fire button, etc., and then convert those into the relevant outputs, whether that's a USB output as a game controller in Windows for using with MAME, or whether that's an output through the DB9 connection to Vectrex and Atari 2600 and potentially other games consoles in the future. The advantage, the nice thing about having this as a micro-controlled version of the board now is that I can just add additional modes in, and the switching allows me to be quite flexible around what I do. And then there's a small OLED screen and a mode select button. So let me just hook those in again. So if I power this up, let's take it off of there and power it up. I'll come back to the chassis in a moment. And then, oh yeah, so boot screen, and then it defaults into Pytrex and Stramash mode on the Vectrex. And then the modes go through to VecFever, so that it uses it maps out to a VecFever compatible control scheme, and then USB mode for PC main, and then lastly the Atari 2600 mode, and then it just loops back round. The other couple of things you can do with this is if you hold the mode button down for what I call a medium long press, eventually it will go into a debug mode, and debug mode is just going to show you a bunch of information around where which switches are being activated, whether the pin 6 output is analog or digital, and that's the one that I needed to be digital for the Atari 2600 but analog for everything else, the mode that it's in, the version of software that's running on it. And then if you do a long press, it'll bounce through because it's going to detect, so it'll turn debug mode off, do a few things, and then eventually it goes into update mode, and then that allows you to connect it to a PC, so that you can just drop any firmware update onto it at a later date if I release additional versions in the future. And then once you've dropped your firmware update file on there, it'll automatically reboot. It goes back into the default splash screen and then straight into the first mode. And that is it. So that's where we're at. This all sits into the chassis. Everything connects into the plug sockets, and then over the top of it all sits the shell, which I need to do a little bit of make a few changes to make it accommodate the larger PCB. So the shell will basically sit over the top of all of this, but it won't go down far enough at the moment because the board's a lot bigger than I originally anticipated to fit all these new components in, and the way that I've shaped the chassis interferes with that. So I need to make the chassis deeper front to back by probably 20 millimeters maybe, so that I can still keep the type of shape that I want, because it looks nice, but also accommodate all of the height of the components that I've got inside now. And that is that. No, there isn't. That, oh man, that's an interesting thought. No, the simple answer is no, there isn't. The longer answer is, if I ever build my skills back to a level where I could do something like that, then maybe. What could be quite fun, one thing I did think about, and it shouldn't be too difficult to code, would actually be to put a little Pong game in and use the joysticks as paddle movement. So you could end up with a two-player Pong game on it, which could be quite fun. Maybe in the future. We'll see. But yeah, no plans to run Doom on it. Although it's probably possible, I would imagine. Anyway, that's all I had planned, guys. Unless anyone's got any other questions, we'll wrap it up in a moment. Hope you enjoyed it. I've certainly enjoyed it. It's been an interesting experience doing a live stream. It's a little weird having the conversation being more one way in terms of the talking. Maybe a Zoom session at some point or something like that. But yeah, I'll certainly do another one of these once I've got a little bit more progress to show. I've got a few kinks on the software to sort out. PC mode works great. I was testing that the other day, and that works really well. The Vectrex mode, I need to do a couple of tweaks because I've got the controls slightly, the logic is slightly wrong. I know what I've done wrong with it. It's just I just need to fix that. It's a few lines of code now that I've got the hardware side out of the way to test with properly, and then yeah, it'll be hopefully ready to actually start producing these things for folks in the not too distant future. Getting very close now. This has been a long time coming, this controller, and I appreciate people's patience with it, but it's been really enjoyable so far designing and putting this thing together. And yeah, anyway, thanks very much, guys. Enjoy the rest of your weekend, and catch you on the airwaves at some point.